Hello everybody, nice to be back. I took a break because I had a little injury and I didn't want to scare everybody with my injury, so now that I'm healed up a lot better, we're back. So sorry for the delay. Just because of the delay and the need to make sure that we have seamless understanding, I am going to go over the vocab very briefly, because in the previous video before this one we have it laid out in a very nice, clean manner. I just for the purpose of being able to support our foundation of seamless understanding and clarity, I'm going to just briefly go over the terms that we did in the briefly go over the terms that we did in the other video, just to make sure we remember. Okay, in the interest of time, I don't want anyone to have to, double up if they don't have to. Hopefully this will help. Hopefully you guys watched that video. I'm sure you watched that video and you have the vocab, and maybe you revisit it again after this. But here we go. So the terms quickly that we're going to be seeing with our beautiful phosphoinositide 3 kinase pathway. Yay! Finally, right? So we just need to brief it up, tighten it up a little bit. So here we go. The first term we're going to look at right here is our phospholipase, right? So it's the protein that speeds up the hydrolysis of the phospholipids in various fatty acids. So whatever the fatty acid is going to be, it's going to break lysis, right? This L-Y-Z-E-S, lysis is back to lyse, means to break. It's going to break that hydro bond in the phospholipids to be able to get things going quickly, right? Our next one is a lipase, right? This is talking about, if you remember, talking about the breakdown, how fats are broken down. A lipase is a protein that speeds up the chemical reactions in the body to break down fats using the same hydrolysis method. Now we have a kinase, which is what? To do the same thing to the phosphate. It speeds up the reaction. So by breaking the HO bond, so it's able to add a phosphate group to wherever it needs to go. Phosphoinositol 3 kinase, transduction signaling, right? So this is what we're talking about. We're talking about the adding on, phosphorylation. Remember, talking about that word. You guys should know that word because we talked about that word in a lot of different videos before even getting to these terms, right? So phosphorylation is talking about the adding on of the phosphate group. Kinase enables the kinase enables phosphorylation, right? Kinase is the break so that the phosphorylation can happen. See? Kinase breaks so phosphorylation can happen. We get it. So anything like that, kinase, lipase, anything with the aces, we know that it's going to be a breaking up, a breaking through. Not something I got too sciencey, right? It's a breaking up so that we can add, like Legos. You put the blocks together, and now you want to create something else, so you break it apart and you add the piece where you'd like it. The end. Okay. Trimer is a complex with 3 parts. Great. A ligand. What's a ligand? Did you say signaling molecule? You are correct. Signaling molecule. What's a receptor? What? You guys are hot with these answers. Receptor is the receiving molecule found on the inside of the cell on the cell surface that we talked about initially. Okay, great. All right, so I think I can rest there. Secondary messenger, before I rest anywhere, secondary messenger is going to be the small molecule that says, hey, we have something going on. Relays a signal has been received on the surface of the cell. Primary messenger is the one that says, hi, how are you? It's the lock and key portion that we discussed before. Now let's talk about really briefly, let's remember our abbreviations, because we're going to get into our wonderful transduction signaling, and we have abbreviations, and we are responsible for knowing what the abbreviations for. We need to know why, because it helps us with our understanding, and isn't it all about our seamless understanding? Yes, yes, yes. So here we are. The first one is phosphoinositol 3 kinase. I've underlined the 4 places where we get our abbreviation from. Phosphoinositol 3 is in the number of where the inositol is. Kinase. So PI3K, right? That's the first one. The second one is going to be phosphodidylinositol 4,5-bisphosphate. The bis just means 2, right? I've underlined again where the initialing comes from. So there you have it. Phosphodidylinositol 4,5-bisphosphate is called PIP2. Okay, PIP2. Phosphodidylinositol 3,4,5. Let me get, can you see that? 3,4,5 trisphosphate. It's PIP3. PIP3. Okay, so now we have our remembering. We got a brief, quick reminder, and I'd like for us to go ahead and look at this video I put together for us. I hope it will help you. Look at it as many times as you need to. If you have any questions, make sure you ask them so we can answer them before we move on. Key, important, and necessary. All right, guys, enjoy this video, and it's pretty good. It's simple. Again, any questions, you know what to do. Ask. And then we'll move on from there. It's going to break down, I'm going to show you the general idea of how it works. General gives you nothing really heady, basics, essentials to get us where we need to be. And this is going to be the pathway that also we're going to look at how it starts off our insulin signaling pathway, how it also helps us understand the basis of how cancer is registered in the body. Cellular, remember all this is what we're looking at is how things present on the cellular level. Then we have physical symptoms as in, organ systems and such. First, we are looking at it from a cellular point of view to get clarity, to get understanding as to this is what this means inside the cell. So we know how things can work when you're putting therapies together, when you're talking to your specialist, when you're talking to your primary care doctor. If you have a clinical nutritionist who's on your team, if you're fortunate enough to know and have one, then these are the things that are going to be discussed. Helps you to understand. And that's really all this is about. This is why the channel exists, so we can get that understanding, so you can understand and not be so overly concerned with, oh, what is that? What does it mean? And the fear comes in from lack of understanding. Okay? All right, guys. All right, let's watch it. Enjoy. Okay. Dun da 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 da.
Phosphoinositol 3 kinases are intracellular signal transducer enzymes capable of phosphorylating the third position hydroxyl group of the inositol ring of phosphatidylinositol. Phosphoinositol 3 kinase is involved in cellular functions such as cell growth, proliferation, differentiation, motility and survival. One well-defined pathway of phosphoinositide 3 kinase pathway is mediated by phospholipase C that hydrolyzes phosphatidylinositol 4,5-biphosphate to produce inositol 1,4,5-triphosphate. A trimer structure is bound to the receptor at the intracellular side. The trimer structure is composed of 3 different types of domains: G-alpha-Q protein, G-beta protein, G-gamma protein. When the primary messenger binds to the binding site of the receptor, it creates conformational changes of the receptor. Conformational changes of the receptor induces the changes in G-alpha-Q protein, and it squeezes the GDP, guanosine diphosphate, from G-alpha-Q protein. At the same time, G-alpha-Q protein creates a high affinity region for GTP, guanosine triphosphate. GTP induces the change of G-alpha-Q protein. Then G-alpha-Q protein detaches from the receptor and other two parts of the trimer structure. At the same time, beta and gamma structures attach to the cell membrane. Detached alpha-Q protein attaches to the cell membrane. It is also named as phosphoinositide 3 kinase. Then PI3 kinase goes away and binds to a membrane-bound enzyme called phospholipase C. When PI3 kinase binds to phospholipase C, it stimulates the activity of phospholipase C. When PIP2 moves along the cell membrane, it moves across the phospholipase C, and it is phosphorylated by phospholipase C. PIP2 breaks down into two molecules. They are diacylglycerol and acetyl 1,4,5-trisphosphate. Hydrophobic diacylglycerol part remains in the cell membrane, and acetyl 1,4,5-trisphosphate goes into the cytoplasm. These two molecules are secondary messenger molecules. Secondary messenger's function is to transmit signal from the receptor site to the targeted site. Outer membrane of endoplasmic reticulum. Inner membrane of endoplasmic reticulum. Acetyl 1,4,5-trisphosphate moves towards special ligand-gated calcium ion channel that is found in the membrane of endoplasmic reticulum. When it binds to the calcium ion channel, it causes conformational changes of the channel. As a result, the channel opens. There is a high calcium concentration in endoplasmic reticulum lumen than outside. Because of that, calcium moves from the endoplasmic reticular lumen to the outside, according the concentration gradient. Some calcium ions bind to calmodulin and creates calcium-calmodulin complex. This complex activates the activity of different types of kinases. As well as calcium binds to specific types of kinases found in the cell membrane, known as protein kinase C. When calcium binds to protein kinase C, it allows to bind diacylglycerol to it. Then protein kinase C is activated by diacylglycerol. This protein kinase C controlling the function of other proteins through the phosphorylation of hydroxyl groups of serine and threonine amino acid found on these proteins. Protein kinase C involved in receptor desensitization, in modulating membrane structure events, in regulating transcription, in regulating cell growth, and in learning and memory. insulin signaling pathway gets started with the identical beginning steps of the phosphoinositide 3 kinase transduction pathway, before branching off into its own cascades. Here is a brief introduction of how the insulin signaling pathway begins. In insulin signal transduction pathway PIP2, phosphatidyllinositol 4,5-bisphosphate is phosphorylated into PIP3 phosphatidyllinositol 3,4,5-trisphosphate by PI3 kinase. This phosphatidyllinositol 3,4,5-triphosphate activates a protein kinase called PIP3-dependent protein kinase. This PIP3-dependent protein kinase activates protein kinase B. Then protein kinase B stimulates the movement of glucose membrane transporters to cell membrane, as well as phosphorylate the enzymes that synthesizes glycogen from glucose molecules.
All right, so I hope you enjoyed the phosphoinositol 3 kinase transduction signal introduction. And as you already know from the video, our next step will be talking about how diabetes presents in our body, cellularly speaking, first. And then after that, we're going to move on to vocab and how, excuse me, how these things, when they in a cellular level, how they're presenting and they get diagnosed as diabetes 1, diabetes 2, as in diabetes type 1, diabetes type 2. So that's going to be our next video that we're going to see. But before we see that video, I'm going to do a brief intro of any terms I think that we need to discuss, and I will do a brief summary on what things I need us to understand before we get to the video, so that we continue in the vein of seamless understanding. So I hope this video is helpful and has helped. And again, watch as much as you need to. I will see you shortly. I should see you back in a week or less, because I am really pumped about getting us here. I'm glad. I want to give you guys time to watch it. So I'll be back in a week, and then we'll be ready to start with our first malady, which will be diabetes. Like I said initially in our very first videos, now I've built this up with understanding, so I'm feeling a lot more confident about presenting this to us in a way that we can get it, understand it, own it, and move on to use it as a tool. So I look forward to seeing you guys shortly in the course of 7 days. That goes by so fast. And thank you for watching. Subscribe to the Dr. Harris channel if you are not already, and share the channel with other people that you love and people that you have in your life, co-workers, such that could benefit, that you think could benefit from having this type of thing, these types of things explained. All are welcomed. All right, until the next time, be well. Thank you.